In questions 10 through 12, you are asked to find the radius of the circle, and you are given a chord, and then you're given a line from the center of the circle, or segment rather, that intersects the chord at a right angle. And if you just think about what you've learned this year, this actually isn't too difficult. So we know that all radii are congruent in a given circle. So I could draw a radius from C to B, or I could draw a radius from C to A, or I could draw a radius anywhere in the circle, but I'm going to need some of this information. So we know that from C to B, that radius is congruent with the radius from A to C. We also know these are both right triangles, and then we also know that this little segment that they share that's 5 feet long, by the reflexive property, it's congruent to itself. So what we end up with are two congruent right triangles, and we can prove they're congruent using the hypotenuse leg theorem. So we said if the hypotenuse and the leg of two right triangles are congruent, then the triangles are. The reason we need to think about this is when we look at this chord AB, we need to know how long just this leg of this triangle is. And I can know that it's going to have to be exactly half of 24, because if these triangles are congruent, then each of these legs has to be 12. So now we have a right triangle with a missing hypotenuse, and that means we just need to use the Pythagorean theorem. So I'm just going to re-sketch this. I know I'm sketching it a little differently. This is point B, this is point C, and we said that we were given that this segment is 5 feet long, and we said that if chord AB is 24 feet, that this part of it is half of the chord. So that's going to be 12 feet. So now we're just doing the Pythagorean theorem to find the radius, which you should be pretty good at by now. So since these are both legs, we'll do 5 squared plus 12 squared equals the radius squared. 5 squared is 25. 12 squared is 144. And then we add this together and we get 169 is the radius squared. If we take the square root of both sides, our radius equals 13. That's also what we call a Pythagorean triple. You've learned about 3, 4, 5 triangles. There's also 5, 12, 13 triangles. So we have solved for the radius, and now you are going to try problems 11 and 12, and you can do these in much the same way, and just make sure you show all your work and feel free to use a calculator.